Problem 3. In the diagram of right triangle ABC, they tell me AB is 14, AC is 9. That's stuff that's already included in the diagram. What you will notice is missing is a variable. We don't know if we're solving for a side or an angle. So if I read on, it says, what is the measure of angle A rounded to the nearest degree? So the angle I'm looking for is up here. I'm going to call that X. So now that I've got a reference angle, I can start labeling the sides of my right triangle. Are we starting with the hypotenuse, which is across from that 90-degree angle? Then we look at our reference angle, and we're going to say, okay, well, the side opposite that angle is right here, and whatever's left over will be the adjacent. And we can see I have information about the adjacent, I have information about the hypotenuse, so the trig function I'm going to use must be cosine, because that utilizes adjacent and hypotenuse. My next question is, well, am I finding a side or an angle? And if I read the question, I'm finding an angle. So it is inverse trig for me. So when I write out the cosine, it will be the inverse cosine. And that's going to be applied to the ratio adjacent divided by hypotenuse. My adjacent is 9, my hypotenuse is 14. And when I'm done with that, that will spit out my angle. That will tell me the value of angle A, which I'm calling X here. So this is fairly straightforward. I just input that information into my calculator. I take the inverse cosine of my adjacent divided by the hypotenuse, and I can tell my angle is 49.994. And this is one that I know immediately rounds to 50, because that 49.9, that's going to round up. It's so close to 50. So we're going to say X equals 50 degrees. In your diagram, if you call it X, you're allowed to use that variable in your final solution. You don't have to say the measure of angle A equals 50. So long as it's listed in the diagram, you can box off X equals 50.